Okay, YouTube, in this video we're going to explore the asymptotes for hyperbole as well as how to find their equations. So basically how to sketch hyperbolas very, very quickly and use their asymptotes as an aid in order to do so, and then just come up with their equations. So that being said, let's go ahead and take a look at this picture that you see that I've kind of provided it for us here. But basically, you'll notice that we have some hyperbola and some center h and k. But the points that I want to point out here, at least make note of, are these. We say that we've got two vertices that are located on the hyperbola, and this would be across what we call the transverse axis here. But the thing that I want to kind of point out here is this is some distance a, okay? And then we say if I went up and down from the center, some distance b here, we said, formerly this was some imaginary axis that we had running perpendicular to the transverse axis. We'd have some value b here. You notice that just by knowing those two values there and deviating left and right and up and down from the center, those distances, what we do is we create this imaginary, box that kind of runs around the center here that is a units left and right, b units up and down, or vice versa, depending upon if your transverse axis runs up and down or not. So that being said, though, the diagonals of this imaginary box are actually the two asymptotes that our graph will approach as x or y, gets very large to the infinities, okay? So that being said, we can just find the asymptotes by forming this box first, and I'll show you how quickly this can be done on this example here, in which we'll sketch a hyperbola whose equation is this. But the other thing I do want to mention here is this, and keep this in mind here. We say that x minus h squared minus y minus k squared equals 1. This would be a hyperbola at first because of the fact that this is a difference right here, but we'd say that this is a squared and b squared, and then we'd say that, it could be vertically oriented, where we'd say that the y term actually comes first, and we get something that looks like this. But in either instance, the thing I want to kind of point out here is that a is always the first number when it comes to a hyperbola. So that being said, what I can tell you is that the equations for, we say a line whose transverse axis is horizontal and vertical are just these right here, where you'll notice that we will just need h and k, which is where the center is located. And I want you to all to notice here that h has a negative in front of it, so h is kind of a liar. It's a backwards value. Whereas k, it has a positive in front of it. So this is going to be honest here. I do want to make a note of that. But essentially, you need the center of where the hyperbola is. And then we would say that, in a case where the transverse axis is horizontal, like what you see here, we would say, well, what's the slope of this line? You'll notice it goes up b and over a, kind of thing going on. So that being said, we would say that its slope right here, this is the slope, we say b over a. But you just need to remember that if the transverse axis is horizontal, you would think it'd be like a over b, but it's b over a. And then, if it's a vertical transverse axis, it's just a over b. But basically, this same equation exists here, okay? And we say plus or minus because you get two asymptotes. So that being said, we say, all right, well, let's go ahead and sketch this hyperbola in this really easy way that this gentleman keeps talking about or talking towards. So the first thing I want to do here is I want to take this, and it's not quite in general form. You see that the right side doesn't equal 0, but it's also not in standard form because the right side doesn't equal 1. So what we're going to do here is we're going to divide everything by 16. We're going to divide everything by 16. So what we get is a simplified version of this equation where we say the 4 and the 16 cross reduce. We would say that I get x squared over 4. So x squared over 4 minus, now we say y squared over 16. And this is all equal to 1. Or you know what, a preferred way to write this, or at least my preferred way to write it, would be with some squared quantities in the basement, because this will directly communicate how far left, right, up, and down we're going to be going. So we'd say that the 4 there is really 2 squared, and 16 is really 4 squared. They just happen to be perfect squares. But we say in this particular case, we can observe that h and k are 0 and 0 up here with our x and y quantities. So we'd say that this is a hyperbola, because it is a difference of x and y squared quantities. And we say it is centered at the origin. Okay, so now knowing this, we would say, well, this is a and this is b. As a matter of fact, I'm going to go ahead and list those out. We say a is 2 and b is 4. Those being listed, though, I basically want to get down to the fact that this is really telling me that since 2, or at least 2 squared, is underneath my x term, just because it's underneath the x there, it means that I'm going to go 2 to the right and 2 to the left. And I'm actually going to go ahead and do that. I'm going to say 2 left, 2 right. I'm going to put dots there. And then simply because of the fact, not because it's b, but because, hey, it was underneath the y term here. This 4 squared, or the 4, tells me I'm going to go up and down 4 in a vertical orientation here. So we say, okay, now I've gone up 4, down 4, left 4, or left 2, right 2. The idea here, though, is this. Since our x term came first, we'd say it's a horizontally oriented axis, or transverse axis. So we would say that the transverse axis is actually here, and we say that this is a vertex right here and this is a vertex right here. So when I said that this is very easy to graph, I kind of said, well, let's go find the center, let's go our x, x and y displacement, identify which way the axis goes. But what I want you to imagine is, because now that I've gone around these, we can imagine that there's this imaginary box that kind of stretches around the center, that when, in this case, A units left and right, B units up and down. But if you were to actually connect I guess the corners of this parallelogram, this right parallelogram, this rectangle, you get these diagonals, and these diagonals right here are actually the asymptotes of this hyperbola. So when we sketch this now, I notice that the vertices have to be these points right here because our x term came first, and this is a horizontally oriented transverse axis. But when I sketch this, check this out. I mean, like I would get something that approaches this asymptote as it goes, to the infinities. So when I sketch this time, trust me, I mean, if we were to impose this grid paper over like, Desmos or something like that, I have faith in myself. As long as I have the vertices right and I approach these asymptotes, then it's going to be solid. That's what it is. So let's say, well, I want to know the equation of this right here. Well, I notice that it goes through 0, 0. So I have a point on this line right here, say this line right here, and I notice it goes up 4 over 2. And I'm only going to note that once because that means the slope is 2. So when we write the equations of the asymptotes now, we say that these are the asymptotes, and we need to know how to find the equations of these. We're basically going to note something here. We're going to say in this case A and B respectively were 2 and 4. So now that I have these here, we say also H and K, this was 0, 0. So now we have H, K, A and B. So to write the asymptotes here, because this was a transverse axis that was horizontal, we have y equals k plus or minus b over ax minus h. So essentially, we're going to get this. We say k, so we say k plus or minus. You would think it'd be a over b, but b over a, since it's horizontally oriented transverse axis. And we say b over a would give us a 4 over 2. And that's the same slope you're seeing here, up 4 over 2. And we say this is times x minus h there. So really the equations of the asymptotes in this case are plus or minus 2x. And you can see that obviously, this is a line that starts at 0, has an intercept of 0, and goes up 2 over 1 every time. So we were able to find the equations of the asymptotes by using this set of general formulas over here. Cheers.